Let's look at methods we can use to solve two types of equations, radical equations and absolute value equations. For both of these types of equations, we can boil down our method for solving to 4 steps. For radical equations, we can isolate the radical, square both sides, solve, and then check. You'll notice square has an asterisk next to it. That's because we might not be squaring. What we choose to do depends upon the root we're looking at. So if our equation has a square root in it, we'll do the inverse of that, which is square both sides. If our equation has a cube root in it, we'll cube both sides, and so forth. For absolute value equations, we also have 4 steps we can follow. Isolate the absolute value, then write 2 equations, one positive, one negative, then solve, then check. Now let's look at an example of each of these types of equations to see how to follow the steps to solve them. First, let's look at a radical equation. The 4 steps are isolate the radical, square both sides, solve, and check. Isolate the radical means get the radical term, the first term in this problem, by itself on one side of the equation. So we'll add that x to both sides. That isolates the radical and leads us to step 2. Since this is a square root problem, we will be squaring both sides of the equation. So square the left and square the right. Squaring the left side basically removes the radical, because a square root and a square are inverses of each other. On the right side, we've got a binomial that we're squaring. So to square x plus 3, we get x squared plus 6x plus 9. What we do for the third step depends upon what kind of equation we have at this point. And what we have is a quadratic equation. That's because of the x squared term. So we're going to get this quadratic equation in standard form, in other words, everything on one side of the equal sign, by subtracting 3 and adding x on both sides. Once it's in standard form, we need to find a way to solve it, and for this problem, factoring will work. So if we factor the right side, we can use the zero product property, which says that one of those 2 factors, either the x plus 6 or the x plus 1, has to be a 0 if their product is a 0. And then solving each of those equations gives us 2 possible solutions, x equals -6 or x equals -1. Now on to step 4, which is to check. The reason we check is that these possible solutions perhaps are what are called extraneous solutions. They're numbers that we get perfectly legitimately by going through all of our steps for solving, but they will not check in the original equation. And the only way to find them is to check. So let's start with the -6. We check by substituting -6 in for all of the x's in our original equation, and then simplifying. When we do that, we end up with a statement 12 equals 3? No, 12 does not equal 3. So we get a false statement, which means -6 is not a solution. Now let's check the -1 the same way. We'll substitute -1 in for all the x's in our original equation, and then simplify until we get to a statement that's either true or false. And in this case, it's true. 3 does equal 3. So -1 is our only solution to this radical equation. Now let's look at our other kind of equation, an absolute value equation. We'll follow our 4 steps for solving that kind of equation. We'll isolate the absolute value, we'll write 2 equations, one positive, one negative, we'll solve, and then we'll check. To isolate the absolute value, we need to go through a couple of steps in this problem. First of all, we'll add the 1 to both sides of the equation to get the term with the absolute value in it all by itself. And then, since the absolute value is still being multiplied by a 2, we'll go ahead and divide both sides by the 2. That isolates the absolute value. Step 2 says to write 2 equations, one positive, one negative. And here's what that means. If we're taking the absolute value of something and getting a 3 as a result, that something we're taking the absolute value of could be a 3, because the absolute value of 3 is 3, Or it could be a negative 3, because the absolute value of negative 3 is also 3. So that leads us to say that 5x plus 2 could be a 3, or 5x plus 2 could be a negative 3. Step 3 is to solve, and we do have two equations to solve, so we'll start with the one on the left. We'll subtract 2 from both sides of that equation, and then to get the x by itself, we'll divide by the 5 on both sides, and we get x equals 1/5. For the second equation, we'll also start by subtracting 2 from both sides, and then we'll divide both sides by the 5, and we get x equals -1. Now our final step, let's just check and see if these are solutions, starting with the 1/5. We'll put 1/5 in the original equation for the x, and then we'll simplify. Remember, the absolute value of 3 is 3, so we have 2 times 3 minus 1 equals 5, which means once we simplify, we get the statement 5 equals 5, which is true, and that tells us that 1/5 is a solution. For -1, we'll do the same thing. We'll put -1 in our original equation for the x, and we'll simplify. This time, we see an absolute value of -3, which is also 3. So we have 2 times 3 minus 1 equals 5, and once we simplify, we get 5 equals 5, which is a true statement. So this absolute value equation has two solutions, x equals 1/5 and x equals -1.